Two pie charts are being used to show the change from 2006 to 2011 in the popularity of petrol and diesel cars. Complete the second pie chart. Let's look at this first pie chart here, just to see where these percentages come from. Here we have the percentage of petrol cars that were bought in the year 2006. You see that 74.2%. Let's just confirm that figure. You don't have to do this, but just to see that everything checks out. The number of petrol cars bought in 2006 was 128,634. And we want to get that number as a percentage of the total number of cars bought in 2006, which is 173,273. And we multiply this by 100 to turn that fraction into a percentage. We can see that to one decimal place we get 74.2%, as you see here. And what about diesel? Diesel is 25.4%. We can see that in 2006 44,010 cars were sold were diesel cars. So as a percentage of the total number of cars sold, we divide this by 173,273 and multiply by 100. So we get 25.4% to one decimal place, exactly what we have here. Now let's look at the situation for 2011. Let's get the percentage of petrol cars sold in that year. Let's look at the number of petrol cars sold in 2011. We can see that it's 23,246. We divide that by the total number of cars sold in 2011, which is 86,932. We turn this number into a percentage by multiplying it by 100. To one decimal place we get 26.7%. Now let's look at diesel. In 2011, 61,730 cars sold were diesel cars. Divide that by the total number of cars, 86,932. Multiply this by 100. And we get to one decimal place 71.0 or 71%. Finally, to get the number of cars sold that were other than petrol or diesel engines, we can just sum these two percentages, 71 plus 26.7, and subtract from 100. Three percentages I have to add to 100, of course, so we get 2.3%. Now, to construct this pie chart, we need to have an angle for the sector representing petrol. That angle will be 26.7% of the angle in a full circle, which is 360 degrees. So we get 26.7% of 360 degrees. 26.7% is 26.7 divided by 100, which is 0.267. We multiply that by the angle in a full circle, which is 360. So we get an angle of 96.12 degrees. I'll round this to the nearest integer. So I'll write down 96 degrees. Now we do the same for diesel. We get 71% or 0.71 of 360. To the nearest integer, this is 256 degrees. And finally, to get an angle representing the sector for cars other than petrol and diesel cars, we could get 2.3% of 360, or we could add 96 onto 256 and take from 360. The three angles must add up to 360, and we get 8 degrees. Now you just need to use a protractor to construct the pie chart. Let's do diesel first. For diesel, the angle is 256 degrees. So we could measure anti-clockwise from this vertical line here, as it was done here for diesel. So we can instantly compare the two pie charts. If we take an angle of 270 degrees, we'll have 3/4 of a circle. 256 is a bit less. It's 14 degrees less than 270. So it's going to look like this. I won't do this exactly, I just do a rough sketch of it. So this quadrant here is diesel. So that's 71%. The other is represented by a sector with an angle of 8 degrees, and petrol is represented by a sector whose angle is 96 degrees. See part 2. Which of the following statements best describes the change over time in the popularity of diesel cars as a percentage of the total? So we need to look at diesel cars as a percentage of the total over the 6 years. So I'm going to write down another column. So for 2006, the number of diesel cars was 44,010. To get that as a percentage of the total, we divide by 173,273. So we get 25.4%. Well, we already have that calculation done actually. It's already given to us. And then we repeat this for 2007, 2008 and so on. It'll be easier to answer the question if we do this. So here are the percentages. This is number of diesel cars as percentage of total. Let's look at these statements. Let's look at A. Diesel cars have suddenly become very popular in the last year or two. Well, you could say that that's true actually. In the last year or two, the popularity, well, the percentage of diesel cars is 64 and 71%. It's higher than previous years. It's a lot higher than the earlier years actually. But 64 is not much higher than 56. So A seems quite plausible. Diesel cars have increased very steadily in popularity over the last 6 years. Very steadily. Well, there has been an increase. Well, we can probably rule out B. Presumably we mean by a very steady increase that the increase is fairly constant over time. See, from 25.4 to 28, that's an increase of about 2.5%. But then from 28 to 34 we have a big increase, or biggish increase, 6%. 34 to 56 we have an increase of 22%. So it's hard to describe this increase as being very steady. Very steady would mean presumably an increase by the same amount each year. So we can probably rule out B. C says that diesel cars have become very popular since car sales started to improve. Well, car sales started to improve in 2009 after a fairly big slump. So let's see what happened in 2009 for these percentages. In 2009 the percentage was 56. And yeah, you could say diesel cars have become very popular since 2009 when the percentages are 56, 64 and 71. There's certainly been an increase in popularity. So C is pretty plausible. Let's look at D. Diesel cars got more popular each year with an especially big increase in 2009. Not really. There hasn't been such a big increase. Well, from 2008 to 2009 there was a big increase, but not from 2009 to 2010. Presumably what is meant by a big increase here is a big increase from the 2008 percentage, which is 34%. Yeah, 34 to 56 is an increase of 22%. That's the biggest increase in consecutive pairs of these percentages. So D is certainly a very accurate statement. Diesel cars became popular as car sales fell, but have been getting less popular as they rise again. Well, statement E is not true. Diesel cars certainly became popular as car sales fell. Car sales fell from 2007, we have a figure of 28%, to 2009, where we have a figure of 56%. Diesel cars certainly became popular in those years, but they continued to become popular after 2009. Whereas it says here they've been getting less popular as car sales rise. Well, that's not true. The popularity continued to increase, so E is definitely false. I think D is the best answer here. Diesel cars got more popular each year. That's definitely true. These percentages have only increased, and there was an especially big increase in 2009 from 34% to 56%. That's statement D is the most accurate statement. Statements A and C are some bit accurate. Well, they're reasonably accurate, quite reasonably accurate actually, but D is the most accurate. Part D. A survey of some of the most popular models of private cars sold in 2011 examined the CO2 emissions in grams per kilometre from diesel engines and petrol engines. The data are as follows. So we want to construct a back-to-back stem and leaf plot of the above data. So I will do diesel engines on this side and petrol engines on the other side. For the stem, I will use the first two digits of all of these values. So I would put 10 here. The smallest value is 107. So for the value 107, the stem is 10, the leaf is 7. And the next stem is 11. We don't have any other value with a stem of 10. We have several values with a stem of 11. What's the smallest of them? Well, it looks like 110 is the smallest. Then we have 114, I think, is the next smallest. After 114, we have 116. Then we have 117. Then we have 118. And we have two 119s. Now we look at the values whose stem is 12. We have 120. We have two 125s. Finally, this value has a stem 13 and its leaf is 4. Now let's look at the petrol engines. How many values have a stem of 10? Well, none of them have. What about 11? None of them have. What about 12? Well, we can see a couple of values that have the stem 12. 129. There's 3 of them. What about 13? Well, there's several of those. What's the smallest value with a stem of 13? It's 133, I think. Then we have 134. 136. We have two 138s. We have a 139. And that's it. Now, I'll write in 2 more stems that don't actually appear in this. We have 14, and finally we have 15. We have a few values whose stem is 15. We have 150, 157 and 159. Does the information suggest that diesel engines produce lower CO2 emissions than petrol engines in your answer you should refer to the stem and leaf plot and to an appropriate measure of central tendency. Well, the answer to that question is yes. The values for diesel engines are further up the plot. See, the small values are at the top and large values are down at the bottom, and you can see that there are far more values for diesel engine near the top than for the petrol engine. Also, if we look at a measure of central tendency, well, the handiest measure to get from this plot is the median. We don't have to do any calculation. To get the median CO2 emissions for a diesel engine, we just get the middle value. So the data are arranged in ascending order if we read across to the left and down. So we have 107, then we have 110, 114, 116, 117, 118. The median is actually midway between 118 and 119. So the median emissions for diesel engines is 118.5 grams per kilogram. By emissions I mean CO2 emissions, of course. So the median is just a middle value. There are 12 values here for diesel engines. So the middle value would be the value between the 6th and 7th value when the values are arranged in ascending order. So the 6th and 7th values are 118 and 119. So the median is just the mean of those two values, which is 118.5. We do the same for the petrol engine. We need the values in ascending order, which they are if we read down and to the right. And then we go along to the 6th and 7th values, which are 136 and 138. So the median is between those two values, it is 137. So we can see that from the median CO2 emissions for diesel engines is less than the median CO2 emissions for petrol engines.